Hey everyone, welcome. This is Jason Clemmons, Doctor of Chiropractic at the Rock Health and Wellness Center, and this is Life with Jason Clemmons, DC. We are live from the Rock Health and Wellness Center studios in Lubbock, Texas. We're on 98.7 Walk by Faith, 1420 AM, 987radio.com. We're on all of our social media pages, the Rock Health and Wellness Center on Facebook. We're on at Health from the Rock on YouTube, and we are on Jason Clemmons, DC on Twitter. This week, we have been working on the practice of chiropractic. And we've been trying to take you through the steps that we do in the office and really give you a really strong fundamental understanding of what chiropractic is, why do we do it, what is it, how is it good for you, why would it make your life better, and just a base understanding of chiropractic. And that's what we've been doing. And we started it on Tuesday. We took health to church on Monday, and then we started part one on Tuesday, and we've been working through that all week. So if you haven't watched the previous shows, please go back and do that. If you're new to the office, if you're thinking about getting adjusted here at the Rock Health and Wellness Center, and you're trying to figure out, hey, what's this guy all about? You can go back to these 4 shows that we've done, and you could really kind of get a good understanding of see if this is right for you. Is this the kind of chiropractic care that you're looking for? Because there's lots of different kinds of chiropractic care, and there's 40 chiropractors in Lubbock. I don't know how many, but there's lots of different chiropractic care, and you may want a different product. And if you do, that's great. We've been at it I'm in my 20th year now. This week is the 25th year that I've been in chiropractic. I got my first adjustment when I was 17 years old. And so it's kind of been almost a lifetime experience for me. And so, but tonight what I want to do is I want to summarize real quickly some of the information that we went over regarding the stress response. And I want to tie the stress response into specific symptoms that you might have. Because you might be thinking to yourself, okay, well, maybe I understand some of this stuff that he's saying, some of this brain stuff that he's talking about, but what does it have to do with me? Like, well, I don't even know if this applies to me. And so I want to take some of this and I want to show it to you. And then if you're new to the office, maybe when we went through your first day and we went through your history, and we walked through all those questions. And I said, hey, is anything else going on with you? Is anything else going on with you? Is anything else going on with you? And, in our intake, it's like, how's your digestion? I ask you about your sleep. What's going on with any other symptom? And you might not have understood why I would be asking you those questions. And that's really fair. It's fair that you might not understand that, because you might say, I don't get this. I have a crick in my neck, and I don't know why he's asking me about my digestion or my sleep. And so I want to go back to some of these and just kind of and just talk about just what we talked about over the last few nights, and just really tie it into symptoms so that you can get a good understanding. Oh, I see what he's trying to say. Like, I see why he asked me that question, right? Because what we talked about is we talked about the brain firing, the information coming into the brain, and the right side of the brain dealing with the unknown world, anything that's unknown, right? And when that happens, anything that's unknown fires your fight or flight response. And fight or flight response is what's called the sympathetic nervous system. Your sympathetic nervous system is your fight or flight response. And that needs to happen, and then it needs to turn off. And it needs to happen really quickly. But if your whole world is fight or flight response, if you're constantly in fight or flight response all day long, you're worried about stuff, you're driving yourself through the world, you're getting driven through the world, whatever your situation may be. If you're having this, then maybe maybe you'll start to see how this is related to your symptoms. And then I want you to reverse engineer it at the same time. I want you to reverse engineer it and say, wait a minute, I'm having GERD, or I am obese, or I am dealing with thyroid issues. And then say, wait a minute, could that be a result of me being stressed and I don't realize that I'm stressed? And so you can kind of reverse engineer some of this stuff as we go through. So just remember that the stress, unknown situations, toxic situations, lack of vitamins and minerals in your body, that's a stressor on you. Like those things all fire the sympathetic nervous system, and they release these neurotransmitters called epinephrine and norepinephrine. It's basically the adrenaline of your brain. And the right hemisphere has an affinity for that adrenaline. And so you're going to get this increased activity in the right hemisphere of your brain. And that's where your anxiety comes from. That's where your worry comes from. We're worrying about that tiger fight, that threat that's on that right side. And that's the big deal when it comes to a lot of this. And you might look at it and you might say, okay, map it out for me. Okay, I want to map it out for you, because as soon as you start this fight or flight response, then your right hemisphere is going to fire down to your adrenal cortex, your adrenal glands. They're two little glands. They sit right above your kidneys. They're the only glands that have direct outside of your head, really, but they have a direct firing mechanism straight from the brain. There's no synapses that goes from the brain, the nerve, and then synapsing to another nerve and then to the adrenal gland. Nope, that's not how it works. It goes straight from the brain to the adrenal gland. And this firing of the adrenal cortex is going to release cortisol. And cortisol drives the right cortex more. So now we're just going to create this loop. We're going to create this loop, which we're going to have more emotion, more worry, more anxiety. So now we've got cortisol being driven, and then here we go, right? Cortisol will also downregulate thyroid-stimulating hormone receptors on the thyroid gland that will slow down the thyroid and lead to thyroid problems. So now it's like, okay, I've got a thyroid issue. I don't understand, like, okay, what would a thyroid issue be? A low thyroid is going to give you're going to be cold all the time. You're going to be overweight. You're going to be out of energy. You're going to be tired. So when your thyroid gland is not functioning, or your thyroid hormone is not functioning properly, then you're going to have a slower metabolism. You're going to have a slower motivation. That whole thing is kind of shut down a little bit. So, and I'll kind of map that out. I'll kind of map it out with you, because as we kind of walk through this. But that's one thing. That's one symptom that overactivation of the sympathetic nervous system might give you. Okay? The sluggish thyroid will then have a greater effect on the left cortex, causing feelings of sadness, lack of motivation, and decreased immune system. Because here we go. Now we've got this downregulated thyroid, so we've got this effect on the left hemisphere, and the left hemisphere is driven by, or has an affinity for, dopamine, and dopamine is what wants to get you up and get you moving. Well, now if you downregulate your left hemisphere, you have a lack of motivation. And there's where your addiction comes in, and I'll show it to you a little bit later in the show. There's where your addiction comes into food, because lack of motivation, it's like, well, who cares? Like, if you get to that point where you're just saying, hey, it's Friday today. It's Friday, and we're doing Friday's show, and a lot of people are going there. Thank God it's Friday, right? That's the thing. Thank God it's Friday. Let's go have a margarita. Let's kill this week. This week wore me out, right? What is that saying? I mean, I know it sounds arrogant, but I'm not in all trying to be arrogant. But it's Friday night at 6:13, and I'm live right now on the radio and the social media talking to you. I'm so excited about this show. And Friday afternoon, because I stopped adjusting at 1, and then I went and got an hour and a half massage. Then I went home and took a shower, got some raspberries and some blueberries, and then came back up here and got ready for the show this afternoon. I don't have a need to kill my week with a margarita. I don't have a need to go eat Mexican food tonight and get a bunch of corn tortillas and have a bunch of chips and eat 4 baskets of chips tonight like I have in the past. And because I'm not having a left hemisphere deficit issue, right? And so you might be asking yourself, if I'm tired of this week, I don't have any motivation. I don't even understand why we're having this conversation, because I don't care about anything. I just want to go have a beer. I just want to go have a margarita. I just want to go eat something that makes me feel good and gives me some sort of reason to move forward, right? That right there, in and of itself, is a symptom. That's your brain not functioning properly. And it'll lead you down the road to other things, right? Because as soon as you get all those chips in your system, you're going to increase your omega-6s, which is going to increase your inflammation, which is going to make your whole body hurt worse. And we'll go on with that. But I just wanted to show you how right brain activity, sympathetic nervous system, fight or flight response has a direct effect on the way that your thyroid gland works. Okay? The fight or flight system will shunt blood from the large abdominal veins and arteries that supply the visceral organs. So whenever you go into fight or flight, if I'm going to fight you or I'm going to run from you, I need to get the fuel and activation, which what I'll show you in just a second. I need to get the nutrients to the muscles that allow me to run and fight. So my body has a system that has the ability to push the blood away from the core of my body into my arms and legs so that I can run and fight. So we'll shunt the blood from the large abdominal veins and arteries that supply the visceral organs to the arteries of the arms and legs in a fight or flight response. This will cause the digestive system to malfunction if the stress is prolonged. Because that's what I said yesterday on our show, is that, and I've said lots of times, the first thing that goes away is digestion. We start having digestion problems. How many of you are on some type of proton pump inhibitor for acid reflux or GERD, right? And we're about to get to that, but that's one of the things that will happen. Because why? Because the sympathetic nervous system is shunting that blood away from your core, and now your organs are not working like they're supposed to work because they're not fueled properly, and it's coming from the brain. And this right now, in this particular moment, this might be the very first time that anyone has ever told you that in your entire life. Like your doctor, when you went to your doctor for an ulcer or some sort of acid reflux problem or some sort of digestive issue, I would be willing to bet you $1,000. I don't even care how much, like we could probably go up from there. I would be willing to bet you that your doctor didn't sit down with you and say, I really think you have an overactive right hemisphere problem, right? Probably not. You've probably not had that. Some of you already know this stuff, but some of you might not have ever heard that before, right? So there it is. And then we also talked about last night, we talked about parasympathetic activity being responsible for sphincters. So the sphincter between the stomach and the esophagus is under parasympathetic activity, which is rest and recover, which is the left hemisphere of the brain. So now we've got the overactive right hemisphere shunting blood from our core, pushing our blood to the periphery, and we have an inactive left cortex, which is decreasing our parasympathetics, which is losing tone, losing muscle tone. You ever picked up something and just dropped it? Like you're holding a cup of coffee or you got a hold of something and you just dropped it, like it just slipped out of your hand because you didn't have enough contraction on that thing, like if I was holding this pen but I didn't have enough contraction on this pen, then the pen might just slip right through my hands. Yeah, that's muscle tone. You got to be able to hold up. You got. Have you ever slouched and someone told you should sit up straight? Like sit up straight, and you're just slouched. That's muscle tone. That you don't have enough muscle tone in order to bring yourself up, and that's not muscle. That's brain. Muscle tone is brain. That's not because you're weak. That's because you don't have brain to muscle connection. And that's what I'm talking about that sphincter. So there's two examples of how an overactive sympathetic firing, fight or flight system, it's going to shunt blood and it's going to decrease the tone of the sphincter, and there's going to be your problem. And I'll continue that in a minute. The epinephrine and norepinephrine of the sympathetic nervous system will break down the glycogen into glucose, because we got to have more glucose now. We're going to, all of that glucose that we stored when we had a high glucose meal, and we increased our insulin, and now our insulin pulled that glucose out of our bloodstream and stuck it in our liver and in our muscles. That glycogen that we have now gets released back into the bloodstream, because we got to get that glucose back up from the liver, right? So we'll get the breakdown of glycogen into glucose, and cortisol will start gluconeogenesis, both causing blood sugar to elevate and cause a depletion of B vitamins as well as cofactor minerals. This leads to an overall malfunction of the metabolic system in the body. So now we're losing B vitamins, and that's bad. That's bad in lots of different ways. Dr. Robert Hadaya, MD, wrote a book, and he made these statements. And, I told you last night, Dr. D'Onofrio is the one that taught us a lot of this stuff. He was the head of the neurology board and a super good dude. And so these slides are the slides that I got from Dr. D'Onofrio. But Brain, Behavior, and Immunity, Volume 25, Issue 3, March 2011, pages 397 and 407. Psychological stress causes almost immediate changes to the gut bacteria population. Psychological stress, whether you're stressed out or just firing your right hemisphere, it doesn't matter which is which. It doesn't matter. Remember, we said physical, chemical, and mental emotional stresses is what causes subluxation. It's what causes the interference in your nervous system. Physical, chemical, and mental emotional stresses can be mental emotional stress, or chemical stress, or physical stress. It doesn't matter which one those are, but those stresses may very well fire that sympathetic nervous system and cause some of this disruption that's going on. And as soon as you have psychological stress, you will change the bacteria in your gut. This change strongly influences the effect that stress has on immunity, because there is a gut-brain connection of your immune system. In the study, the researchers exposed mice to social disruption, which is known to cause increase in circulating cytokines. And we talk a lot about cytokines in the office, which these increased cytokines is an increased inflammatory response, the hormones of the immune system, which themselves induce enhanced reactivity in the immune system. So now we started with the gut. I gave you two examples of why your digestive system might not work properly. And now we talked about how the thyroid gland is being affected. Now we're talking about how the immune system is being affected. All from this same problem that we're dealing with. And he goes on in his book, social disruption altered bacterial counts of some gut bacteria subpopulations, particularly when the bacteria were assessed immediately after stress exposure. Stress exposure increased the relative abundance of bacteria in the genus Clostridium, which often causes prolonged and severe diarrhea, generally after antibiotic use. So now we've got diarrhea we can add to the list. The stressor also increased circulating levels of interleukin 6, which is inflammation. Now the inflammation is a problem because now that's going to start to decrease the function of our joints. That's what your arthritis is. Arthritis, joint inflammation. So now you say my joints hurt, or my muscles hurt, and my body hurts. I'm sore. Like I got this knee thing that's going on. I got this SI joint problem. I've got this increased amount of inflammation that's stressed. But at the very same time, sometimes we need inflammation, right? There's times where we need an inflammatory response inside of our body. That's why we want to balance the 6-3 ratio, but we don't want it to get too far out of control. And this says in a second experiment, make it a little bigger here. In a second experiment, these researchers found that a combination of antibiotics prevented the stress-induced increased interleukin 6. So now, the natural innate wisdom of the body that when we got stressed would increase the interleukin 6, now this inflammatory response gets dampened whenever we have antibiotics. This means that certain gut bacteria are necessary for stress-induced increases in circulation of cytokines. That means that we need the gut bacteria to help us when we need it to help us. There's a time that those gut bacteria are helpful for us, and there's a time where they're out of control, and we need to keep them under control. And one of the things that antibiotic use does is it disrupts the balance of the gut bacteria, which causes the good guys and the bad guys, I call them crackheads all the time, the good guys and the bad guys get out of balance inside the gut. So the ones that we need, we can't get, and the ones that we don't need are overactive. And so now here we go with this whole thing. So now we get into psychiatric disorders such as OCD and depression, as activation of interleukin 6 has clearly been associated with depression. So here we go. Now we're adding to it. And that's really what I'm just trying to do in this first part, is I just want to keep showing it to you, where now we can add, we've added thyroid, we've added digestive problems, we've added immune system problems, now we're adding depression, because we can get into some issues here. We can now see that stress, via its effect on gut bacteria and hence immune system, can change brain function. Yes. We know this because of these enzymes, and I'm not going to get into all of that sort of thing, but one of the things is that it steals or siphons off tryptophan from normal metabolic pathways, conversion into serotonin and melatonin. And that's a big problem in like insomnia. That's one of the problems that we have with insomnia, is serotonin becomes melatonin via B vitamins. But if we have decreased B vitamin activity, which I'll get to in just a second, now we can't make these conversions inside the brain. We can't convert tryptophan to serotonin because we have a lack of B vitamins. And then that's going to affect our left hemisphere, and it's going to make us more sad. And we're not going to get our melatonin working right, so we're not going to be able to sleep properly. You see how all this, when you really start studying it, there's just a lot of it. The results of all this is increased depression, anxiety, and reduced memory. Because memory is right hemisphere, but language is left hemisphere. Have you ever had that moment where you can't remember somebody's name? It's on the tip of your tongue, and you just can't remember it? It's because you're not getting right to left transfer. The right brain knows their name. The left brain is what's going to say their name, but the left brain can't remember what it's supposed to say because the right brain can't communicate with the left brain. Have if you've ever spoken to someone that's got dementia, someone that's got dementia, they'll start a conversation and it'll be like you know, I w- when I was over there, you know, uh, we were both over there. Don't you remember when? Um, yeah, you guys have had that. If you've ever talked to a dementia person, you know exactly what I'm talking about right now. I've got a patient, and we're dealing with it right now. We had this conversation yesterday. And it's just like his language center on the left side is not receiving the information, the big picture information from the right side. And so he can't remember what he's supposed to say. Memory is a right hemisphere to left hemisphere problem. That's what's going on with memory. Okay. So stress, the gut, the brain, the immune system are really intimately linked and inseparable. So your diet is chemical stress, and the chemical stress from your diet can change the way that your brain functions. And you might not even realize it because you might not have ever had anybody map it out for you and say, "Oh, now I see what you're saying." Like this ultra processed food that we eat, when we just go get a bunch of crap at the grocery store, and then we come home and we eat all this stuff all the time, it constantly keeps our brain in sympathetic stress, and it messes up our right side, left side brain activity. We got to take a break on the radio, but we'll be right back in a few minutes. And then I'm going to get into I'm going to keep going with this real quickly. And then I want to show you um, how this all ties together. So stick around with us. We'll be right back. Okay, I'm going to keep going um, while we're waiting right there. But this is um, elevated noradrenaline is a factor in various types of cancer. Diabetes, open angle glaucoma, osteoarthritis, rheumatoid arthritis, and asthma all have an increased sympathetic firing connection. Bipolar disorder, excessive body weight, and hypertension, they all are involved in the elevated noradrenaline, which is right hemisphere activity, tend to be comorbidities with those diseases. So here we go again. My diabetes is a problem. It's like you're saying to me that I can get diabetes from having overactivation of the sympathetic nervous system, and I'm saying yes, you can get diabetes from having an overactive sympathetic nervous system. That's what I'm saying. You can get glaucoma, you can get cancer, you can have osteo and rheumatoid arthritis, and you can have asthma. And all of that stuff has a correlation with the way that the sympathetic nervous system fires. So all neurons need two things. All nerves, and we've talked about this lots of times on the show, is fuel and activation. We need fuel and activation. What does fuel mean? It's oxygen and glucose. Okay, we need that oxygen and glucose. What I used to teach the kids when they were growing up is the brain needs three things: glucose, oxygen, and excitability. Right? The activation is provided by sensory stimuli. The activation is movement. The neurons, in order to stay healthy, your nerves, in order to stay healthy, need movement. Your body needs movement. Your joints need movement. You need movement from your feet. You need to be able to bend your knees. If you ever want to watch something really cool, watch the Blue Zones on Netflix, because the Blue Zones on Netflix does a fantastic job. If you don't even have to listen to it, if you just watch what they're doing. The Okinawa people in Okinawa live the longest of anybody on earth, and they don't even have chairs in their living room. Those 98-year-old people have to sit on the floor and stand back up. It's activation, constant activation. One second, let me get us back on the radio. Okay, everybody, we're back. This is Life with Jason Clemmons, DC, and we're covering a lot of stuff this week. because we're talking about chiropractic. And I love this subject. So that's what we're talking about tonight. And what I just said while we were on the break is that all neurons need two things. We need fuel and activation. Fuel is oxygen and glucose. So we've got to have nutrition, and we've got to get exercise so that we can get oxygen to the tissue. And then in the process of exercising, we're going to be moving our feet, which is going to activate those nerves, which is going to keep those nerves healthy. In order to process the glucose properly, we need B vitamins. In order to have energy, we need B vitamins. B vitamins are very, very essential to life, okay, in so many different areas. The fight or flight response increases the epinephrine, resulting in glycogen breakdown to glucose. Also causes cortisol release, resulting in gluconeogenesis. We just went over that, right? Therefore, increased demand of B vitamins and oxygen to utilize increased glucose properly. So it's diet. Diet is vitally important to health. If you want to be healthier in all aspects, there's really nothing, there's almost nothing you can talk about with health that is separate from the fuel and that we're getting into the body. And so when we are eating processed foods, it's causing a problem for us. It's really causing a problem for us. So too much sympathetic firing results in a decrease of B vitamin reserves, resulting in decreased Krebs cycle activity. Krebs cycle activity is the energy that we use in the Krebs cycle goes into the electron transport chain in this whole process, and that's where the mitochondria inside your cell create the ATP that your body works off of. And if you don't have the right nutrients, you're not going to have any energy. And if you don't have any energy, you're going to dampen your left hemisphere and you're going to lose your dopamine, and you're going to create a decreased amount of motivation. When you're tired, what do you do when you're tired? When you're tired, you don't want to move and you want to eat, right? Why do you want to eat? Because you've lost that dopamine in your brain and you want some external source of dopamine to give you motivation. There's where you're going to go have your margarita tonight. I know you guys aren't, because you guys are listening to me right now. Well, yeah, you're not out eating a margarita tonight. You're sitting here. Later on, someone else will catch up with the show, and they'll be like, yeah, I was out having a margarita on Friday because thank God it was Friday, right? Yeah. You should check that out. That, like, if you really wanted to be super awesome as a human being, and you really wanted to stay away from these things, because there's two motivating factors. You either want to play to win or you want to play not to lose. Either way, I can win the argument on both sides, and I'm not even arguing with you. If you want to play to win, it's vital. If you want to play not to lose, if you want to just stay away from disease, then it's vital. And what diseases? Chronic fatigue syndrome, fibromyalgia, ulcers, obesity, GERD, irritable bowel syndrome, leaky gut, ulcerative colitis and Crohn's, autoimmune conditions, decreased libido, infertility, erectile dysfunction, thyroid problems, digestive issues, immune system dysfunction, depression and anxiety. Now, when you came in and we went through your first day and I started asking you all those questions, that's what I was asking you. When I ask you if you have any anxiety or depression, I'm asking you that because I'm trying to figure out the physiology of your body and the neurology in your brain. I'm not trying to meddle in your life. I'm not trying to get into issues and try to. I'm not your therapist, as far as that goes. But I can tell you that your therapist is not going to be as effective if your brain's not working properly than your therapist would be otherwise, right? So it's really important. So I don't care. I'm trying to ask you all these questions. How does your sleep? How's your digestion? How's your immune system? Do you have any anxiety and depression? Is there anything else? And that's why I go through what I'll usually do with you on that is I'll go back to your first page of your intake form and look at what medications you're taking. Because a lot of times that's where we can have this conversation. We can have this conversation because we went through some of the things, and then I say, why are you taking this medication? Oh, that's for asthma. Oh, okay. Why are you taking this medication? Well, that's for high blood pressure. Well, why are you taking this medication? Well, that's my statin drug. Well, why are you taking this medication? Well, because that's my, whatever my thing is, my acid reflux problem. Understand this, ulcers, because ulcers is on the list, right? Ulcers is H. pylori. H. pylori is a bacteria that's in your gut. H. pylori can't live at normal pH levels. If your stomach acid is proper, you're not going to get an ulcer. It's not from H. pylori. If your stomach acid is proper and your brain is proper, you're not going to have acid reflux disease or the GERD. But here's what's going to happen if you are on a proton pump inhibitor, because you've got these parietal cells in your stomach that make acid, okay? And so you've got your vagus nerve involved, and eating is parasympathetic. So we're only going to eat when it's rest and recover, right? When we're out of a threatening situation. When you're in a threatening situation, you don't want to eat, right? Like if you're really threatened, then you're just like, I'm not hungry right now, right? So we need to be in a parasympathetic type of situation to eat. Well, now we've got the vagus nerve, which is working on this parietal cell, and so we're having this whole problem with our stomach acid, and it's really a lack of left side brain, okay? But then the stomach acid is getting into our esophagus, and it's burning, and it's causing problems, and so we're going to go to the doctor, and the doctor is going to give us a proton pump inhibitor. Well, one of the things now we're going to turn off the parietal cells, and in the process of this, we're going to lose this substance called intrinsic factor. And intrinsic factor is made by these parietal cells as well, and intrinsic factor helps us absorb our B vitamins, especially B12. So now we've got a problem of absorbing the B vitamins that we need in order to run the Krebs cycle and in order for our body to function the way it's supposed to be, because we've cut the stomach acid out. So in our office, if you've got acid reflux problems, as we're working on your brain, we're going to try to give you a product called Zypan or Zymex, which is increasing the stomach acid in your stomach. We do not want to turn that system off. We really don't want to turn that system off at all. We want your stomach to function properly, and we want your brain-stomach connection to function properly. Obesity, what's obesity? Well, we get cortisol, and cortisol, because we're firing our sympathetic nervous system. Our sympathetic nervous system is firing our adrenal gland. Our adrenal gland is releasing cortisol. Cortisol is increasing our blood sugar, which is going to increase our insulin, which is going to cause us to retain calories. And at the same time, cortisol is going to downregulate thyroid stimulating hormone, our thyroid function. So now we're going to burn less calories. So now we're going to have an increased amount of weight gain because of this whole process that's going on right there. Those are just the big things that I wanted you to see in that have a lot to it's interference in your nervous system. I think if you get that, I'm subluxated. I'm not out of alignment. I have interference in my nervous system, meaning my nervous system is not firing properly. There's an imbalance in my nervous system, and that's called a subluxation. And it could be anywhere in the nervous system. It could be in the brain. It could be in the knuckles. It could be in your wrist. It could be in your elbow. Those are all subluxation areas, but you can have it in your muscles. You can have it in your fascia. You can have it in your ligaments all over your body. Okay. So what are some of the things that we might can do to drive the different sides of our brain? Let's actually start with our right brain. So if I wanted to try to increase one side of my brain, now in my practice, unless I really need to specifically drive your left brain, I'm going to start with your right brain because I believe in the idea of increasing the amount of voltage to the right hemisphere and kicking all that information to the left. I think we can increase the left hemisphere by ramping up the right and kicking it, getting it out of there. I think sometimes we just don't have enough power to the right hemisphere to allow us to get it to the left. So I'm going to spend a lot of time on the left side of your body to drive your right brain, unless your body's just really telling me to do the opposite. And that's why each time when you come in, I'm going to have you stand right in front of me, and I'm going to look at the way that you're standing, because your posture is going to give me clues as to what's going on inside your body. Okay? But here's some things you can do to drive your right hemisphere. All right? Smell under your right nostril. Take something that is common to you. Take some cinnamon or coffee, something like that. And then cover your left nostril and just smell. Just take that and take the lid off of it and just cover it and just smell with your right nostril. Your nose goes to the same side of your brain. All the rest of the sensory information goes to the opposite side of your brain. But your smell is above that area of the brainstem, which now there's not a crossing over, and it just goes straight up to that right side. So if you're going to ramp up the right side, you can smell under that right nostril. Drawing and coloring is great. Looking at pictures, especially things that are blue and green. The green is, your brain has an affinity for green. We have in our office, we've got green sunglasses and red sunglasses. That when you go into the gym and you do your brain rehab stuff, and you get on the vibe plates, or you do your laser glasses, or you do your the iPads, or any of the things that we have for you in the gym, sometimes we'll just put you in red glasses or put you in green glasses, depending on which side of your brain we're trying to fire up. Okay, so drawing and coloring, looking at pictures, music in the left ear that is classical or jazz, something that's foreign to you. Okay, or even background music, something that you just kind of, that you're focused on something, but you're alert or vigilant to your environment. And the alertness and vigilance is from that right hemisphere. That's where we talked about attention yesterday, right? So attention is those four types of attention that are in that right hemisphere. That's where background type of music comes in. Or you can just put headphones in the left side and then listen to music, because that'll drive across to the right side. Spin to the left with eyes locked on the thumbs. So you would stand up, you'd put your thumbs right out in front of you, you would lock your eyeballs on your thumbnails, and then you're just going to spin all the way around in a circle with your eyes looking at your thumbs. Now, if you have balance problems, please do not do that and fall down. And if you think you might have a little bit of balance problems, stand in the corner of the building or in a room someplace where you can, if you had to, you could reach and grab the walls. If you have a stool or something that you can sit on, you can do that as well. But you're going to spin to the left. Okay? Pursuits to the right. So, and I'll get in this, and I think I'm going to get into this in just a second, but there's two parts of your brain that control different eye movements. So pursuits to the right is just watching something move slowly from left to right. When I pursue to the right, I am firing the parietal lobe on the right side. The other one is quick eye movements to the left. So now I'm going to put my hand in the middle, I'm going to put my other hand to the left, and now I'm going to look at one finger or I'm going to look at the other finger. Or I can look at the camera and I can look at the lamp. And so I can look quickly to the left, quickly to the left, quickly to the left, and then pursue it back. So here's another way that you can do it. You can hold your thumbs out or your fingers out, whatever you want to do. Go quickly to the left and then pursue it back to the right. Look at this finger and then quickly to the left and then pursue it back to the right. So just pull your left hand back towards your right side. That's activity of the right hemisphere of things we can do. Okay? Now, if we need to do the left hemisphere, we're just going to basically switch all those. We're going to change them up a little bit. Smell under the left nostril. If we're trying to drive the left brain, we're going to smell under the left nostril. We're going to do easy math problems. One of the things you could do is you can count down from 100 by sevens. So just start 193 and just work your way down and just count down by sevens. Okay? That's an easy math problem. If it's too complicated, count down by 3. 100, 96, 93, 95, 97, 94. Yeah, not 96 and 93. But do easy math problems. Music with a beat in the right ear. So now put the music in the right ear and not the left ear, and now listen to music with a beat. Something that makes you tap your foot. Okay, something that you like, some rock and roll or something like that. Talking, having conversations, saying your prayers. Okay, that's a big one. Say your prayers out loud to yourself in your prayer time, because saying your prayers is activating your brain. You activate your left brain. That's why your prayers, there's a spiritual component to it and there's a neurological component to it. In my life, those two things are the same thing. I think the spirit runs the neurology personally. And so those two things to me are the same thing. So it's like God gave us a way to calm that right side down. All that anxiety that's on that right side will get calmed down by saying our prayers. Because once we get the left brain, if we're overactive in the right brain and underactive in the left brain, if we could bring the left brain up, it will start to shut off the right brain. So you say your prayers and you dampen the anxiety from the right hemisphere. And then spin to the right with your eyes locked on your thumb. So you're going to spin, do that same thing, put your hands out in front of you and spin in a circle to the right. And then we're going to switch those eye movements. Now I'm going to look at it. I'm going to do a quick eye movement to the right, and I'm going to slowly bring it back to the left. A quick eye movement to the right and slowly bring it back to the left. That will activate my left hemisphere. If you're depressed and you don't have any motivation, those are things that you can do to get that left hemisphere to ramp up a little bit. Okay? So that was a summary and some action steps that we can do to all of that stress that we've been dealing with. Now I want to go back to this article that we pulled up last week real quickly. And I just want to point out a few things now that we've had this conversation, because these articles have so much more meaning when you understand what they mean in depth, right? And this one is autonomic dysfunction in the motor of chronic critical illness. Annual update in intensive care and emergency medicine 2013. So these are some guys at intensive care medicine, St. George Hospital, London, and University of College London. Okay, whole group of these guys together. Okay, but what I really wanted to point out is it's what I mentioned it a little bit this week. The precursor of autonomic nervous system. Autonomic is just the big picture way of saying fight or flight and rest and recover. Okay, your autonomics is your parasympathetic and your sympathetic firing, what we've been talking about this whole time. So the autonomic nervous system uh, is a feature at the onset of critical illness. Persistence of autonomic dysfunction in established critical illness. Several cardinal features of chronic critical illness support the assertion that autonomic dysfunction is a core mechanism underlying the development and perpetuation of multi-organ failure. Okay? It's autonomic dysfunction is a core mechanism of multi-organ failure. When you have disruption, because you can start to see it, right? It's like now we're not getting energy to the cell. Now we're not getting, because now we've got this disruption in B vitamins. Now we've got decreased thyroid stimulating hormone. Now we've got lack of energy to the cell because of all of this stress and the cortisol and the left hemisphere depression and the right hemisphere overactivation. And what might that do to the cell of the heart? What might that do to the cell of the liver? What might it do to any of your vital organs that you need, right? And this is a crucial article right here, I think. Autonomic abnormalities can be detected in pre-disease states, such as pre-hypertension. Autonomic brain precedes blood pressure problems. That's what I think of every single time with high blood pressure. I think of brain first. Why is my brain driving my high blood pressure? Why is my brain, what if your brain is driving your heart attack? What if your brain is driving any cardiovascular disease in your body? What if your brain is driving your diabetes, which is causing your sugar problem, which is causing your neuropathy in your feet? It's really critical right there. Persistent sympathetic activation and parasympathetic withdrawal establishes an autonomic dysfunction and fuels multi-organ dysfunction of varying severity. If you're subluxated, you're working on increasing your chances of having multi-organ failure. That's the way that I read this article. It's the subluxation. People ask me sometimes, and if you guys, I coached college football for 6 years. People ask me, do you miss football? And the answer to that question is no, because 25 years ago this week, I learned what subluxation meant. And I have spent 25 years deep diving into what subluxation means. Like that, like it's so deep. It's like it's the subluxation. You're saying to me that just getting adjusted in removing the interference in my nervous system and reestablishing right side and left side brain balance might save my life? And I'm saying to you, yes, that's exactly what I'm saying. And I'm not making it up. I've got volumes and volumes of science, not voodoo, not craziness, not quackery, science, neurology and science that says getting adjusted and balancing your nervous system can help you stay away from some of those things. Now, it's not the only thing. It's not just adjustments, but it's also nutrition and it's also exercise, because it's fuel and activation. It's oxygen, glucose, and excitability. Those are the things that we're going to work on. When you get adjusted in our office, you're going to go across the hall and do your brain exercises. Why? Because it's vital. And I've got people that just walk out of the office, and I hope you're not one of them. I hope when you come to see me that you have listened to some of this stuff and you're like, I get it. That's what I want. I want my brain to function right. I want my right side and my left side of my brain to be balanced and functioning right. And it, because if it's not, persistent sympathetic activation, which we just said, persistent sympathetic activation is related to cancer and GERD and thyroid problems and digestive problems and immune system dysfunction, right? We just went through all that. That's what the article is saying. parasympathetic withdrawal. Parasympathetic withdrawal is depression. Parasympathetic withdrawal is lack of motivation. Parasympathetic withdrawal is decreased muscle tone around the sphincters of our body. Those are all parasympathetic withdrawal. It's established autonomic dysfunction and fuels multi-organ dysfunction in varying severity. Yeah, it's really important, and that's what we do, and it's super exciting. So we've kind of run out of time for tonight, but next week when we get back, we're going to really start to look at some things like, what do we do when you come into the office? What are some of these things that you're gonna get? Right? You're going to get a health evaluation report, and we're going to have all of the things that we do here in the office in your health evaluation report. We're going to have your right eye test. We're going to look at how your brain is firing. We're going to look at your reflexes. We're going to come in and say, what is the parietal lobe doing? What is the frontal lobe doing? What's going on with your balance? So how's your vestibular system working? We're going to evaluate all of those things for you, and we're going to try to balance your brain and give you the best chance to live as healthy a life as you possibly can. That's all I got for you. I'm out of time. I'll see you guys on Monday. So I hope that helped, and I'm really excited about next week because we're going to just keep this thing going, and we're really talk about some of the things that we do to evaluate you. So you guys, I'll see you next week. Have a